Hello, everyone, and welcome to our talk about enhancing the UX to engineering workflow with Qt Design Studio. My name is Andrew Babkin, and I'm a senior UX designer at ICS.
And my name is Taimur Tanveer, and I am a Qt consultant at ICS.
ICS has a 30-year experience in software development and an unparalleled ability to blend engineering expertise and insightful UX design. ICS and its design studio Boston UX has helped many companies from various industries, including manufacturing, automotive, life sciences, and consumer to create projects that get noticed. You can argue, but one of the key factors for succession of your project is the way your design team cooperates with the development team. You can have great UX, great developers, but you may never end up with a quality product if there is no good connection between UX and development. We're not going to talk about best practices of team building today, which is also super important, but talk about the tool which designers and developers can use together to benefit both sides. I believe this talk will be interesting to designers who are hesitant to start using Qt Design Studio or just started with it, as well as developers and stakeholders. If we look at the conventional development workflow as a timeline, in a nutshell, it would look like this. UX UI design starts early, and once the design is approved and established, the UX team begins working on specifications for the development team. And only once those are ready, the development team kicks in. There may be some issues with this approach.
Yeah, and the first of all, I believe the main issue is development team can only communicate with the design team through specifications and review meetings that extends through the development time.
Prototypes will probably appear too late in the process to make important adjustments in hardware, backend, or design. Design team is user testing with wireframes or Figma prototypes, which influences the user experience. Designers can quickly lose control over the look and feel of the UI. Some animations and transitions can be omitted by developers or implemented in a different way, losing the original idea behind it.
Yeah, and developers sometimes may find it annoying or unimportant to adjust placement of objects on a pixel level or tweaking animations. And this is mainly the main thing. Developers own the code and designers own the design, but design implementation is in total control of the development team.
Let's see how the development timeline changes once we add the Qt Design Studio. Qt Design Studio is able to solve most of these problems and bring the development workflow to the whole new level, as well as the relationship between designers and developers. From a design standpoint, Qt Design Studio adds capability as it allows designers to actually build some of the UI themselves with proper UI states and animations. These can be tested on end-user hardware early in the development process, almost at the start of the project, which is a great advantage for designers. To be able to see designs come to life early affords designers the opportunity to test and iterate and really get the design right for the user. This early prototyping also benefits stakeholders and project owners because they too can see the design early, understand exactly what they're getting, and if it's not exactly on point, still have time to course correct. These graphics may look nice and promising, but let's dive into details a little bit and see how the process really looks from a designer's perspective. This is a Figma project for the respiratory emergency device, Project Red, which we worked on recently. The project has a lot of screens and components, and we obviously can't work on all these during this short talk, so let's focus on the starting screen. Even though in our design, these are two separate screens, this is actually the same screen, but with two states, loading state and loading completed state. We also would like to have some basic animation when the device is turned on, um, which gives us a total number of 3 states. As you already know, there is no need to build these screens in Qt Design Studio by hand, even though it's totally possible and actually fun because, well, there is Qt Bridge for Photoshop, Illustrator, Sketch, and there is one for Figma as well. It's pretty new, but already does the job. This plugin lets you import your design assets right in Qt Design Studio as QML files. Yes, it means no more specs to write. Now let's take a look at the number of elements we have in the screen and decide if we are going to animate them or create additional states, because this influences how we organize the document in Figma. What we have here is our screen background. We have additional background elements. They're just dark gray, and we probably will apply some basic animation to it. The title, which also will have an animation. The logo, which looks like lungs, so let's animate them as well. We have properties with some basic flyout animation. Begin setup button. This button will have states and animation. The load and spinner obviously will be animated, and a little text load and please wait will have a basic animation. So before we push the export button, we need to do some edits to our components in Figma to save time later in Qt Design Studio. We will need several states for the begin setup button, which is a component, and it will be reused in other screens of the project. This button has 5 states designed in Figma: default, pressed, selected, and disabled. If we leave these 5 states as standalone components like that, the plugin will import them as 5 different components. Obviously, we don't need that, so we will merge them into one component so that later in Qt Design Studio, we will just enable or disable visibility of each layer for the state. After our manipulations, the component will look like this. Next, we need to take care of the screen itself. Since we have 2 mockups of the starting screen, let's merge them together into one. So it will look like this. Next element is the load and spinner. In order to animate it properly in Qt Design Studio, we just have to make sure that each piece of that spinner is a separate object. We can import it SVG or PNG in this case because it's preferred for our embedded device. And here's the spinner, which is ready for export. And at this point, we're ready. And here's how our project looks in Figma. And by the way, if we had other components or screens in the project which we didn't want to export at this moment, we could just select export as skipped in the plugin. And the plugin outputs a zip archive, which we have to extract to any folder we like. Now it's time to leave Figma. Hit export, leave Figma, and go to Qt Design Studio. So we start Qt Design Studio, create new project, and import our design files located in the output.metadata file from the archive. After a little while, the import will be completed, and we will see that our new components will appear in the Components tab and new QML files in the project tree. So basically, each QML file corresponds to a component or a screen, meaning frame in Figma. Everything looks the way it's supposed to, but it's currently static and nothing is going on here. To start animating it, we obviously need a timeline. We define the total duration of the animation, which can be easily changed in the process, and we create the timeline. The timeline looks really similar to any keyframe animation tools out there, like After Effects, for example. So your experience should translate here really well. All you need to do is to take an object, add a keyframe on the property you want to manipulate, like size, coordinates, color, opacity, and so on. You can also use the auto key feature where you just manipulate the object in the WYSIWYG editor, and Qt Design Studio automatically keyframes every change. Once we've animated all the objects on the screen, one by one, we can end up with a timeline like this. As you can see, here I just manipulate coordinates and opacity of the objects, like the title, um, uh, the loading spinner, and so on. And using the same approach, we can animate individual components here, like the logo, because I'd like to add a breathing animation to it, and the loading spinner. So let's jump into that. The spinner animation timeline will look like this. And here I just fade in and fade out each of the sections of the spinner with 100 milliseconds time offset. The logo animation timeline is also fairly simple. It's just increasing and decreasing the size of the object. The big part of this animation in particular, and any animation involving movement, is easings. Easings are really easy to set up in Qt Design Studio. All we do, and it's very similar to other timeline-based tools, is right-click the keyframe and select Edit Easing Curve, which opens a familiar dialog with a whole set of presets and the ability to create your custom easings. Designers are able to fine-tune these animations right here, and there is no need to create it in other tools providing long descriptive specifications on each easing. This to me is a huge time saver for both developers and designers. So that's animations. Next, let's see what kind of work designers would perform on components like the button in our case. Our button must have 5 states in total, and we have to make sure all these 5 states look and behave the way they're supposed to. After the import, the button component has a separate background for each state, which makes state creation fairly simple. That's because we took care of that in Figma. States are added by clicking the Create New State button, and this way we add the following states: default, pressed, press selected, selected, and disabled. And all we need to select is to select each state and make changes to the tree so that when the default state, for instance, is selected, only the layer for default state is visible. To register user input, we need to add a new component to the base state, which is called mouse area. And it's it's like an invisible rectangle, which defines the area where the component will register users tabs. Once all the states are ready, what's left to do is to add when conditions, meaning rules when each state is triggered. These conditions can be pretty complex, and this is one of the areas where designers can work together with developers or leave this up to a developer to specify later. Designer's goal here is to make sure every state looks exactly the way it's meant to be. Now let's go back to our screen and see how everything looks together. It's looking good, and I think we're ready to send these results to Timur. With Qt Design Studio, I can give Timur ready-to-work QML files with finalized design and animations instead of just a huge amount of mockups and specifications. At this point, Timur will start to work on development, but my part is not over. I can work on other screens and components, and at the same time support Timur on the development process if any questions occur.
Yeah. Thanks, Henry, for showing such a wonderful demo of Qt Design Studio and importing such a useful medical user interface from our favorite our favorite graphical software, our designing software, to Design Studio. And at this stage, uh, I will be discussing a few steps that are involved in the development lifecycle using Qt Design Studio and Qt Creator. Mainly, these are the few steps that are followed when developing an application using Qt Design Studio and Qt Creator. So first of all, when our designer gives our user interface design, we have so when it's finalized, we take the design from the designer, and if some tweaks are involved, we may do some changes inside those component files, and then we test those simulation to test the application logic. And once it is done, we go through the integration with the QML application, and then the final backend development starts. So at this stage, a developer would import all the UI design files from the designer. So at this stage, if these components are translated perfectly, that's great. That's the best thing a developer would want. But if not, uh, a developer would need to tweak these files manually. These tweakings may include changing type of component, sometimes adding background color or the image component, and sometimes the dynamic behavior or even calls of the component are also required to add or change. The next step would be simulating application logic. This requires QML files such as JavaScript file that contains mock data. And sometimes you may also need to check the behavior of dynamic controls or screens using simulations. These simulations can be generated and tested inside QML code using JavaScript, C++ backend, or sometimes MATLAB Simulink files. So there are two major steps that developer use to follow. The first one is JavaScript one, and the other one is using C++ backend. So when a developer using the JavaScript integration, this process involves obviously those JavaScript file that contains the mock data. So in this case, for example, we create a JavaScript function which is called by a timer after every 10 milliseconds to generate data. Like in this case, as you can see in the example, there is a property timer, which is obviously a timer type, and it is run continuously. And on triggering, a JavaScript function called name1timer is called after every 10 millisecond interval. The other process we can use to simulate our design is using C++ integration. This requires QML files as well as C++ classes. So in this case, C++ classes are used to acquire data from the device. So this C++ class is exposed to QML using QML register type and set context property functions. Like in this figure, you can see after a developer has instantiated this design data class, there are two functions which are QML register type and set context property. So these two things are used to expose our classes to the QML environment. So when everything is done, at this stage, if the UI is good for integration, we integrate this UI with our Qt Creator QML application. So at this stage, we are using our backend C++ services. So in this case, the C++ functions are used to receive data from our medical device, and it is used to receive functions which obviously receive those firmware data and all the local variable data involved or may be used for the medical device. And the next thing would be we should call these services from inside the QML file, from inside those UI QML files, which is the purpose of this section. These exposed C++ functions are then called from UI again using some user action. For example, you need to uh, draw some data, acquire some data using a click function or using threshold data, uh, which may increase or decrease. So depending on that slider information, you may need to acquire the data or get some threshold information. So we may use these C++ backend services and call them inside our QML files. So our whole backend development procedure includes, but obviously these are not limited to, first we need to interact with the front end, and then this interface, these C++ classes interface with the third-party APIs, like you want to export these data to some web resources, like you want to share these information, some patient information or anything you like, to the cloud data. So in this case, we would be needing some web engine data interface. That is one example. And the other thing would be, we need to require data acquisition from medical devices and those sensors and actuators which are attached to those devices. And finally, we will test our finalized design and then deploy it to our hardware. But the main thing is, using Design Studio, even at this later stage of the development, if there are some UI updates that were the main requirement, or at the last stage there are some changes that were required, which were I mean, at the last stage is sometimes it's difficult to compensate new changes in the design, but using Design Studio, it is very simple because there is no interdependence between the designer and the developer. So finally, the bottom line is, developer can work in both designer and developer's language using the Design Studio software. And obviously, the developers can get a taste of both the designer and developer working environments, and which results in less time is spent on integration due to low dependency factors. And finally, easiness of the real-time deployment and testing is the main thing that Qt Design Studio provides to its developer and designer. And the last thing would be, functional integration with the UI is made pretty much simpler than its predecessor softwares. So at this point, I would pass over to Mr. Andrews so he may give the bottom line or the summary of the designer's platform.
Having used both traditional design tools and Qt Design Studio, I want to say this. Yes, there is more work upfront with Qt Design Studio, but the benefits of using it far outweigh the detriments. With Qt Design Studio, designers get much more control over the quality of the UI and can really own the design. Plus, Qt Design Studio streamlines the workflow from design to development and strengthens the designer-developer relationship. You will spend more time building your components and states in Qt Design Studio, but you will save a lot of time later on numerous iterations with the development team. The visual result you'll achieve will be much better than what's possible using a conventional development process. And this is how we're enhancing UX to engineering workflow with Qt Design Studio. We tried to be as short as possible and at the same time cover most of the aspects of the process. We're happy to answer any questions you may have. Thank you.